All right. So I don't have my squishy balls with me, but who in here has seen the SDN solution, the SDN controller? Okay, so a few folks. All right. We're gonna kind of collapse. Ethan was gonna do the demo piece, and I was gonna do the presentation piece, but in the interest of time, I'm gonna collapse that down. Who in here knows what software-defined networking is? Few. Who in here knows what, you better have answered that right, Jason. Who in here knows what software-defined networking for the OT space is? Yes, the guys from Interstates and Sandalwood all know. I'm very happy that you answered it that way. All right, so that's kind of the goal, right? So SDN's been around a long time. Let's say 12 years, give or take. It started in the cloud space, and the goal behind it in the cloud space was to make it easier to manage the network without having to run around, swap a lot of cables, make it easier to make changes to the network, because obviously cloud infrastructure is huge, right? It's not your grandfather's D-Link network at home kind of thing, right? So when the companies like Google, Intel, and these companies that are building out this cloud infrastructure decided they wanted to stop paying Cisco $8 bazillion every time they needed to do something, they started a foundation called the Open Networking Foundation. And it's a organization that kind of started, it was the nexus for this concept of software-defined networking. And so that went on for a while. And then if you're in the enterprise IT space, you have heard of SDN. You might not be using it in your particular facility yet, but somebody's thinking about it. SDN is rolling through enterprises these days for the very same reason it was in the cloud. It's an easy way to manage vast networks, right? WANs, I mean, as my friend Haslam back there will tell you, some of these corporate WANs are just big, huge, and complex. So to not have to run all over the place, move cables, reconfigure things individually makes a tremendous amount of sense. So that brings us to the OT space. And I will tell you that a few folks have tried SDN in the OT space. Their problem was this: they didn't understand the OT space, so they took SDN as it is and said, well, we'll just do it down there. Buzzer, not gonna work, right? There's not many of us like Pat O'Dell who like those 2 o'clock in the morning phone calls when something goes down in a plant. He strives and lives for them. The rest of us, not so much. So when we put stuff out on the plant floor, it needs to be designed and it needs to understand that environment. Right? Traditional SDN doesn't. So if you ask Schneider Electric, oh, it failed, we tried it. You didn't try the right thing. Ask Belden, oh, we tried that, it failed. No, you didn't try the right thing. So when we started taking a look at what software-defined networking brings to the table, I'm going to say we identified about 6 gaps in how SDN works, generally speaking, as it applies to the plant floor. And we decided that if we were to bridge those gaps, what would that mean? So we did that, right? We took gaps like, at 2 o'clock in the morning when you've got an electrician and he's got to replace an I/O module. Can you imagine? I don't want to beat on Cybersecurity a little bit, but I'm going to. Which one of your electricians could do a certificate exchange between a PLC and an I/O module for a TLS-based 1.2 certificate? Anybody? Anybody? None of mine could. Yeah, I know yours can't. Right? That's the problem. The other problem is, okay, that's Cybersecurity. What if I'm using Profinet? What if I'm using Modbus TC? What if I'm using something else? So then am I going to have a custom solution for every one of these? Because we all know that Siemens and Rockwell, for example, are best of buddies, and they share technology all the time, and they never do things that would be contrary to the other person's networking solution. So that's always in the best interest of the end users. Maybe not, right? So that's another big problem, is how do I have one solution that it doesn't matter whose device is at the edge, I can secure things? Again, SDN. So the plant floor, the life cycle, the maintenance, I've left this up there. I'm sure you've all perused it. I'm not going to read it to you. All of our PowerPoints and presentations will be available. You can have any of them. But the first thing I want to kind of talk about is what is SDN? So SDN utilizes this concept called flows. And what a flow is it's how we think about things on the plant floor. I need this PLC to talk to that robot over Ethernet IP. Okay, then I'm going to set this PLC to talk to that robot over Ethernet IP. And that's all I have to do. Now, do I have to go to all my different switches and, okay, this guy's got to come here and I got to be on port 7? Nope, throw it out the window. Not important. Network takes care of the rest of it. All I need to do is say that PLC should talk to that robot over Ethernet IP, and I don't care how many SDN switches are in the middle or SDN capable switches are in the middle, it's going to happen. Okay? Who likes VLANs and adding lots and lots of VLANs to your plant floor switches other than the interstates guys? Right? VLANs are for what purpose? Anybody? Somebody get a ball. Throw the ball to the answer. Anybody but interstates, Sandalwood, and Haslam can't answer it either.
VLANs are for pain.
VLANs are for pain. I agree. VLANs are for segmentation, right? That's traditional networking's answer to segmentation. In the world of SDN, there are no VLANs. They are unnecessary. When you create flows between devices, you are micro-segmenting the network. Vastly more granular than you could be with a VLAN. But again, in traditional SDN, there's a lot of work to make that happen with something like Ethernet IP. If your controller understands specifically what Ethernet IP is and what has to happen for that PLC to talk to that robot, that I/O module, that HMI, then that controller is smart enough to lay in the appropriate flows to make that happen. Okay? And that's what happens here. The other thing that's interesting to note about SDN is that you can manage the network, have some automation, do things like change set management. And I'm not going to get into all the great gory details of the thing. But at the end of the day, this is a tool that, if you choose to, your electrician can handle easily, right? How you configure, so here's my answer to SDN and configurations. You can be as simple or as complex in the configuration of your SDN network as you want, but you will never need a VLAN. You do not need spanning trees or ring protocols or DLR. I don't need DLR. It doesn't give me anything I don't already get with SDN. So in the world of a flow, if I wanted, for example, that PLC to talk to that and on display, I wish I could find my new slides for this. I've got some nice new ones. I would create a flow and I would say this guy can talk to this guy over Ethernet IP. I use a pointer too, right? So, or I guess I'm not going to use the pointer because it's not pointing. Okay. SDN is also deny by default. You'll find that if you talk to me at all, you'll know that I preach deny by default. And there's lots of good reasons for why things on the plant floor from a security perspective should be denied by default. I will happily have that argument with anyone. Anybody tells me you should power up something fresh out of stores that it's allowed by default has never audited their plant floor to find that 237 of their 500 security appliances are passing traffic because that's how they come out of the box. And what is the controls, or what is the electrician's understanding of something working? The HMI is working, he can see lights, buttons, he can make the machine move, things must be good. Perfect, right TJ? If it's all working, everything's solid. Well, if your security platform isn't denied by default and you put a brand new one in and it just lets things through, you're no longer secure, but as far as everybody knows, you're all set because you're making parts, okay? So that's kind of important. So in this instance, the only thing that gets through is Ethernet IP. Now, if I were to break that, in the world of SDN, it will completely and immediately recalculate the flows necessary to reroute that traffic the second fastest way to get there. In the world of SDN, we use this thing called the Dykstra algorithm. It's been around since 1960s, right? Strangely, it's still the fastest algorithm to calculate the shortest distance between 2 points. So we use that algorithm to calculate if I have a PLC and it needs to talk to that and on display, and I've got to get Ethernet IP from point A to point B, what's the fastest way to get there with the least amount of hops? It'll figure that out. If I break and lose that primary path, it will know within microseconds what the next fastest way to get there is and lay those flows in. We have some technology we're working on that will predefine a bunch of flows and it will give you sub-millisecond failover, okay? Today, it could take a few milliseconds-ish, right? I don't know. It depends on the connection and how far, but in the near future, you'll be able to do it with sub-millisecond failovers, right? So the whole idea of needing DLR technology or MSP or hyperring or anything, it's out the window. You don't need them. They bring nothing to the table but unnecessary complexity. So here's kind of how this works. If the PLC wants to send something to that nut run over Ethernet IP, right, it sends the traffic to the switch. The switch says, do I have a flow that tells me this traffic on ingress is allowed to get to that nut runner? If the answer is yes, it just happens, right? Once the switch knows what it knows, it never needs to know anything else unless you make a change in the configuration. If I cycle power to the switch, it still comes up happy, okay? So if the traffic is known and you've already got a policy or rule that says I'm good with Ethernet IP between that PLC and that nut runner, gorgeous. You could have a rule that says I'm good with all PLCs talking to all nut runners, in which case that would also be good too. Or I can say these 5 PLCs can only talk to these 3 nut runners and only over Ethernet IP. You can do that. You can be as granular or as broad scoped as you want. One of my favorite quotes from Spider-Man the movie, it was Uncle Ben to Spider-Man, is with great power comes great responsibility. My friend Ken Lively and I used to have this conversation regularly, that just because there's an open switch port on the switch doesn't mean you should plug something into it, okay? SDN does not do away with the idea that you should really set your network up properly. However, it greatly simplifies that. And we've been preaching for years, based on technology, you need to segment your network. Lots of VLANs, lots of layers, lots of levels. What did that do for us? Well, within the context of the technology available, it gave us segmentation and security to a point. In the world of SDN, for those of you who have those great big honking flat networks, this is it. You can make a network as flat as you want, and with SDN, you still microsegment the network. So all those companies and places that have big flat networks, SDN is the perfect answer for security, because you're microsegmenting the network. This whole idea of layers and segments and physics, that goes out the window because it's all virtually segmented much, much, much more efficiently. What if it's allowed traffic, but I've never seen it before? So when the traffic comes in, the switch says, I've never seen this traffic. I've never seen this guy try to talk to that guy over Modbus TCP. So it's going to go to the controller with the very first packet. Everything else is blocked on ingress. Nothing gets in. And it's going to ask the controller, do you have a policy that either allows all PLCs to talk to these nut runners with Modbus TCP, or is there a policy that says this PLC can talk to that nut runner with Modbus TCP? If the answer is yes, the controller will instruct the switch to create the flows necessary to allow that communication. You'll have an audit trail. You'll see when that device plugged into the network. You'll see when somebody plugged it into a port on a switch. You'll know exactly when it tried to talk. You'll know what protocol it tried to talk. You'll know who it tried to talk to and when it tried to do it. Okay? Every protocol, every device, anywhere, period. How many of you guys have had VLAN trunking set up on switches? Then you've got, this VLAN and that VLAN, and electricians might come in and do some maintenance, pull a few cables out. When they're all done, they put them all back, and they don't necessarily put it back into port 3, which is what you're using to trunk data back to your enterprise database. Ever happened to anybody? No? Yeah, a couple of hands, right? Lived it. In the world of SDN, it does not matter. It is not switch port centric. It does not care switches and ports. It's devices. I could take any single device, move it to any single port on any SDN network, and if I have allowed that thing to talk, it will talk. If I take my laptop and plug it, I could have a supplier who's allowed to talk to this machine, that PLC, because let's say it's a tire machine and it's highly, the IP is very, very tight-knit. They don't want anybody else to see it. In the traditional world, if you wanted to isolate that off a bigger assembly system, you'd have to have lots and lots, but don't get me wrong, I think you should all put 300 or 400 ICS defenders on an assembly system, right in between every single switch port of every single device. Is that realistic? No. But if I want that guy to be able to see his tire machine and he happens to plug in 17 stations away, with SDN, the only thing he sees is his PLC and his tire machine, and nobody else sees it, nobody knows it's on the network, and they can't access it, touch it, or smell it. So you can absolutely isolate their traffic easily. What if it's explicitly disallowed traffic? I may have a tendency towards the Rockwell. Maybe, possibly, there's a bias in my mind on Rockwell. So I tend to pick on Siemens when I need to pick on somebody. And in this case, if we're going to explicitly disallow traffic, it's going to be Profinet. Right? I do not want Profinet on my Ethernet IP network. I remember years ago, I don't know if you remember this, Ken, when guys would walk in with the drivers on their laptop that had a Profinet driver. They'd plug into one of our lines that was Ethernet IP, and then stuff on that line would go nuts because it just didn't know how to handle that traffic, right? Well, with this, the very first packet that gets sent in, it's going to have a rule in the switch already that says block all Profinet on ingress. So the very first packet gets tossed. It'll never make it past that first packet entering that port, ever. Okay, you can explicitly disallow traffic. So think of it as pre-configuring or predisposing your network to not like Profinet. Okay, maybe you don't like FTP. Good reason, right? You can predispose your network to not like FTP, which means anytime somebody plugs in something that tries to do, maybe they can talk to their PLC with Ethernet IP all day. They can ping their PLC, but it ain't going to let them talk FTP to anything. Okay, because you have to allow it by devices, by protocols. Okay. So in this case, what's going to happen is the switch is going to say, nope, we don't allow Profinet on my network. My controller already told me that. However, it's going to tell the controller that somebody plugged this device into port 3 of this switch, and it tried to communicate to this device on this switch using Profinet. It was blocked. And by the way, this is the first time we've seen Profinet attempted on our network. All of this is happening in nearly real time. You are not, this is not an application that lives on the network, soaking up network bandwidth, which is sometimes at a premium on a controls network. It's the network fabric. It's not different than anything you do today. Any network you have today can be SDN. Any application, any devices that work on Ethernet, now IEEE 802.Ethernet will work on this network. The difference is only how the network is managed. Okay? So everybody goes, well, this is different. Will my app run? Does it work today? It'll work. Does it run on Ethernet? It'll work, right? All right, so in lieu of the rest of my slides, which there's a lot of other good information about them, we're just going to jump over and take a look at the controller. So, as I'd mentioned previously, I have had to change around some of these demos. I'm now using demo equipment on the SDN network on that wall. That was not my intent, so bear with me if I trip over anything that I just set up on the fly. So the cool thing about this is you get a topology display that literally shows you what's plugged into your network on what switch where. You don't have to create it. How many people have drawings on the floor and they know their network drawings are accurate? Because they're constantly updated, they're regularly redlined, and people regularly update them and redeliver them back to the floor. Sergio's shaking his head. I know, right? Doesn't happen. Well, what if it just drew your network for you? What if I plugged something in and it just showed up in the port of the switch it was plugged into? You know, what if I came over here and I said, okay, let's look at my switch. What have I got here, right? I can scroll down and see the switch. I can see what's plugged into the switch. So I can see that my switch peer is port 1 at 1 gigabit. It's plugged into port 1. I can see that I have these connected devices on that switch. I can pick a device like my laptop and get this thing out of the way. And I can see all kinds of stuff about that. In fact, I can tell exactly where this is plugged in. Simply by looking at the device, I can tell that I am plugged into this switch called SDN8 Zone 3 on port 5. You walk over and move it, I'll see that it's on port 6. If I walk over and put it on a different switch, I'll see it over on that switch. Okay? And I get all of this information in nearly real time. I have a VM running so that I can be, so SDN can run two ways. It can run out of band, which means you have a completely separate network, physical network of cables to run the network, which is that the truly most secure way? Absolutely. Is that something that's going to typically fly in manufacturing? For the most part, probably not. Nobody wants to run a whole nother separate set of networks. So we have this other concept called in-band management, where the management takes place across the data network, but the latency and any additional traffic is very, very negligible. Excuse me. So in this instance, I'm running an in-band network. That whole row over there is one in-band network. Who likes out-of-band networks? Our aerospace companies like out-of-band networks, right? For obvious reasons. You know, as an end user, my biggest fear might be that something fails in an axle when somebody's leaving the dealership or something along those lines. You know, if you happen to run the Palo Verde nuclear facility, your biggest fear might be a 50-mile mushroom cloud over central Nevada. Maybe our concerns are of a different scale, right? So that will drive what type of network you put in play. The beautiful thing about in-band is you've already got networks in place that work. Use them. Don't have to add a management network. So I've got two devices on this network. I've got a VM running here, and I've got my laptop in the host here. So if I come over to my VM, so while I'm waiting for that to shut up, I can do something like this PLC, my VM, and it's going to show me the fastest path through the network. Okay, I can do something like, well, I'm going to control traffic here. I'm going to allow SIP, or maybe I'm going to block it, right? I'm going to allow ICMP, which is ping, or I'm going to block it. And in this instance, I'm picking these two devices. I could go here. I could say everything of type HMI is allowed to everything of type PLC over Ethernet IP, and I'm going to allow it. So now I don't have to go, he can talk to him, he can talk to him. If I know my HMIs are, whatever, and I know my PLCs are Rockwells, and I want all my HMIs to talk to all my PLCs, I just created a policy that allows that to happen. What happens is it actually creates a rule down under here that looks like allow protocol SIP on devices laptop to here, or allow protocol HTTPS, or down here it's block protocol, right? So the rules actually get translated into something that looks like this. Let me see if my VM is up. All right, so my VM is on my controls network. I'm attempting to ping, and hopefully it going to sleep won't make this fail miserably, but we'll see. I'm trying to ping that PLC from my laptop VM, which is on the data side of this network. Can't do it. If I come back to my controller and I do something simple like this PLC and my VM are allowed to talk over ICMP. When I do that, if my VM didn't get hosed, oh look, now it's allowing pings through because it's laid in the flows to allow that to happen. If I go turn that back off, the flow stops. Now, can I see the PLC over Ethernet IP? Nope. Guess why? I have no policy that allows it, and I'm explicitly blocking Ethernet IP. Could I go to the web page on my PLC? Can I get the web page to even load on Edge? Right? If I go to 172, type, hello, wake back up. 21.0.61, is that right? So that's the web browser on that PLC. Well, guess what? I've not allowed HTTP through. But if I do this, you can see where that went to none. That hint to me tells me that it's seen that traffic, but there's no policy allowing it, so it's being dropped. If I do an allow, and I go back to that device, oh look, there I are, right? So I have absolute granular control over anything talking to anything on any port of any device of any switch, okay? Other cool things you can do are, you can, let's see, this is kind of what the rules look like. You can get to the point where you can write those rules yourself. A lot of times now I just type them in because I know what I want to say. You can have a rule that says allow any to any, which of course means that anything can talk to anything over anything. The other big thing is, and you might have heard me talk about learn mode on the ICS Defender earlier, I'm fundamentally lazy, okay? I don't like to do a lot of extra protocol type work. So if I know I'm starting a lineup at a supplier site, what's one of those big gaps? Well, if you have a machine or lines being built by somebody and you're not over there to let them in, let them do this, let them do that, you're going to get banged for extra money. You're slowing the project down when it's really because the tooling wasn't ready, but they're going to blame your switching, your network. So how do you do this with a supplier side network? Well, the easy thing is you just put the controller in learn mode and walk away. And anything that wants to talk to anything is going to talk. It's going to write a flow to allow that to happen. The other nice thing about that is you will have a visible picture of absolutely every protocol, every device, and every conversation that's going on in your network because the controller is now learning it. Every switch that sees every packet on ingress is sending that to the controller saying, hey, I've got somebody trying to talk here under learned rules. I can turn my learned rule policy off. Other cool things we can do, we've got a really powerful northbound API. I think I tried to show you in Fusion earlier. Well, I don't have Fusion installed there, so that's not going to work. Where you can access that northbound API with Fusion, for example. You can access it with lots of stuff. But some of the cool things you can get from that are what's the status of all my devices. So we feed that into Fusion. We feed it into other systems. How many switches do I have when we add new switches, new devices, all that kind of stuff. And without dragging this out too much further and getting to a few questions, one of the examples I was going down that road for is we actually have a demo that we couldn't do here where you actually swipe your badge, and with the Northbound API, we allow you to talk to your device from a badge swipe. And as soon as we decide you don't need to, it turns it off, right? That's pretty powerful. I don't care where you are on the network, where you're plugged in, what port, anywhere, right? Because everybody says to me about DLR I'm gonna turn learning mode off just so it doesn't keep distracting me. You know, the big problem with something like DLR or traditional switching, if you don't go literally manage every single port of every single switch, is I can break that ring and plug in anywhere, and there's nothing stopping me from doing it. And I can see everything on that DLR network. That doesn't matter here. Have at it. Plug into a switch anywhere. You only get what you get. And if you got nothing, you get nothing, okay? So all of those things that are troublesome in the OT space are solved by this solution. You know, troubleshooting alone, and I don't have time to go through all the different alerts and all the different categories of things, but you can see protocol was detected for the first time, new rules were created, HTTP detected for the first time. So there's other cool things you can do, and one of my favorite is this one. Have you guys ever had to troubleshoot between the PLC down there and the test equipment down here between 6 switches because the Ethernet IP just doesn't seem to be getting where it needs to go? Ever had to do that? But you don't know where it's not happening. What do you have to do? Well, Mr. Lucky you get to go span port every single one of those switches, collect all those up in Wiresharks, and then figure out how they all go together in some sort of synchronized way you can actually read the traffic and understand what's happening. Here, I just tag that conversation as monitor instead of allow, so it's still allowed. But now every single switch is going to funnel back to the MAC address that I put in that field right there. If that's my laptop and I run Wireshark, guess what? I have the entire conversation point to point, end to end. No need to do anything fancy. I can see the whole thing. And I'm only going to see the Ethernet IP traffic, so I don't have to weed through all the other crap, right? Now, could I create a flow that says I want all traffic between here and here? Any? Absolutely. Tag that as monitor. I will get all the traffic between those 2 devices. Do you have a question, TJ? No, I didn't. Okay, well, then no yawning, right? So those are some of the examples of change sets, right? You can do change set control. You know, maybe Callian or Sergio want to go make a change to the network so they can queue up a bunch of changes they want to make. Ken has to approve it. And if Ken doesn't approve it, they don't happen. Or Ken can go in and edit their change set and say, that one's okay, that one's okay, that one is not okay. I'll approve the rest. It'll get laid in, okay? And again, unlike a lot of those other solutions out here, I mean, you hear a lot of great things about a lot of great solutions. They are all visibility without control. Everybody here who's ever been on a plant floor always has they can always drop what they're doing and go deal with the security problem that's happening on the plant floor network, right? So if production's down on your top paying line in the plant, but all of a sudden something nefarious appears to be happening on a different place, you guys can all drop what you're doing, tell the plant manager you'll be back in a little while because I have to go figure out why we're seeing Modbus TCP on this network for the first time and we never have. Controls guys, and this is one of those things that if you haven't been one, you don't get. Your job is to keep stuff running for the most part, and your job is to make sure production is running. So you might not get back to that. I saw Modbus TCP on my network for 4 or 5 hours, a day, 2. How much time do you think an attacker needs to compromise your network if they have that level of access to it? I have guys on my team could probably do it in about 20 minutes, okay? Ethically, of course. Ethically, absolutely ethically. So my point is visibility without control is not security. It's throwing a lot of data at you, hoping you have the time and resources to respond. You do not. People on the plant floor do not. I remember a day when, and Ken will remember the day, when we had 20 controls engineers out at Three Rivers, Michigan. So when you brought suppliers into the plant or shutdown, you could put a control engineer with absolutely every project going on and with every supplier. Pat, remember the day when you could have lots of controls guys? That is not the day. So now you're going to have 4 controls guys, 12 projects, and you got to figure out which one of those projects needs the controls guy. And Pat will invariably send JT out to the toughest, nastiest, meanest problems, right? Well, then how are you going to stop people from uploading somebody else's PLC or your SCADA PLC or your whatever over someplace else? Visibility without control is not even half the equation. Visibility is great, control is required. In this case, you can preemptively decide how that control happens. I can shut the controller down completely and everything keeps working. Kind of nice. Controller doesn't have to be there. Once the network is configured, the controller is not required. However, there's a lot of reasons to leave the controller running, right? Some of it's visibility, enunciation. But the nice thing about that is if the controller blows up, put it in recovery mode. Let it go figure out what's out on the network and rebuild itself. That's another big difference between traditional SDN, right? In the world of controls, if you have a backed up PLC project, you have a PLC running production on the floor, your backup is from 6 months ago. You try to log in and it says, should I upload or download? What's the right answer? You get a ball for this. Do you download your unknown PLC project to that running production PLC? Sure, Joe's like, yeah, I know. Right? That's a career-ending decision right there. That which is running production in the event you don't know is king. In our world, if you connect to the network and let's say you backed up something on Friday, you're running it on a virtual machine, it blows up, you bring the controller back up, it's going to go out and figure out what's running production and rebuild its rule set based on what it sees in the switches running production. It has not got to take a brand new configuration or an old backed up configuration and cram it down to the floor, because as you know with PLC code, something's changed somewhere and something's going to break and you're going to hear about it about 2 o'clock in the morning, right? There's a lot of gaps, there's those 6 gaps like that, and that's kind of what I was talking about. I don't want to spend too much more time, we have a lot of stuff to cover. Obviously, as with all of our products, there's a lot of capability we haven't talked about, a lot of functionality that's available. This is the tip of the iceberg with the SDN control solution. We have a whole new line of SDN switches that we're releasing. There's a couple of them over on the table, unless Dave Smith from Interstates has already put them in his bag. He and Marty are itching to get their hands on them. They should be, hopefully the target is to have them production ready within the next 2 months. They're small, they're fast, they're not expensive, and they bring everything to the table that you need.
That's 2 weeks.
Ed, don't listen to Ed.
You said you can pick this one and we'll get you more in 2 weeks.
Don't listen to Ed. No, Jeff said he would have tested prototypes in 2 weeks. That's not saleable production units. We do have production switches today. As is always the goal, we're making them smaller, faster, more robust. IP67, 1U, IP30. So you can see some of our SDN switches running over here. We have partners. SEL makes a SDN switch that's really designed for the electrical grid and relay and substation stuff. I say that because they have more certifications on that switch than I can spell. I know a lot of those already because it's what I do. I had to Google a solid half of them. I'm like, what's that? And then I go read up on it and go, yeah, that's not me. No, I don't need that one. I don't need that certification. Okay. All right. Are there any questions I can answer on SDN? We have a 3-minute window.
So I'm going to pick on DLR since you like Rockwell. So with a DLR ring, especially in existing customer scenarios, DLR doesn't matter to SDN itself, but does SDN play with DLR? So when you've got devices that are all linked in their ring that don't know SDN, don't know anything about it, but for whatever reason, the skid manufacturer or the company in and of itself that put this ring in decided it was going to be far better to reduce the port capacity on the switch that was required or reduce the length of the runs required for the Ethernet. Can you play with DLR anyway?
There you go. So the question was, how well does SDN play with DLR? The short answer is DLR pretty much plays with DLR. That's why we have these things called ETAPs, because as a general rule, you don't let DLR go anywhere but the DLR network because it does nefarious things to other parts of networking. In our case, turn off the ring supervisor in your PLC or your device or whatever it is, and then they become 2-port switches. In which case, 2-port legacy switches, that's another place that we play that traditional SDN doesn't. You can plug a legacy switch into an SDN switch and you'll get control of the stuff below that legacy switch. You won't get the visual because we don't know where it is down there. We know what port it looks like it's coming into on the SDN network, but we can still control the traffic to a point. SDN has this terrible habit of beaconing, right? So every 50 milliseconds, it throws this beacon out around the network. Imagine, if you will, a couple hundred SDN switches all getting this beacon for the first time going, oh, I better send this off to the controller for evaluation. Controller answers about 1,000 questions. It goes, yeah, no, throw it away. Guess what happens 50 milliseconds later? I think we'll throw these beacons up to the controller, see what we should do with them. Up they go. So that's what we call system-generated drop rules. So the system will create a drop rule that says, yeah, you send me a DLR beacon once, don't ever send it to me again. Don't need to see it. Make it go away, right? It's also not true that you have an existing network and you have to go in and change all the switches out. Not true. The biggest challenge today is obviously north-south security, east to west. What solution do you have today if you have a switch with 16 ports? If I plug into one of those ports, how do you stop me from talking to the other 15 devices? ACLs. Can you do that with an old Octopus 2, Dave? Oh, nope, guess not. Right? And everybody loves to manage exhaustive ACL configurations and lists because it's awesome, right? You can put an SDN switch. I've had a customer right now who's got a whole bunch of like a Stratix 5700s right in his panels, and he comes back to an aggregate switch. Well, guess what? Unless he comes up with a whole bunch, well, he's got his production VLAN, but what does that mean? That means, technically speaking, any one of those 5700s on that network and any one of those panels can see every other 5700 and every other panel, which means it can see all the devices below it, right? In the world of SDN, I have absolute control east to west across any switch. So what if I took that aggregate switch out, instead of replacing my 100 5700s, I just took that aggregate out and I put an SDN switch in. Oh, guess what? One switch, and I've just isolated 200 operations from the other 199. I just took control of east to west. Now, am I going to go replace all those 5700s? Not today, but guess what? The next program where I build equipment, that'll be an SDN switch, and then I'll have absolute control, right? So the myth is that you need to replace all your switches. Not true, okay? Let's see. I'm trying to think of all the different areas where this is a little bit different. Jason, what have I missed?
You missed so many cool things.
I don't have that kind of time. I'm just thinking of gaps. Ken?
The levels.
With an SDN switch in place, what does that do for asset discovery?
That's a great question. You're like a straight man. Thank you. If I go look, I didn't cover any of that. You get a real-time asset inventory of what's on the network. Okay? If I look down here, I can see, for example, this Rockwell PLC. Somebody overwrote it and put HMI in here. I'm going to find out who did that. Because it would have identified that as a PLC. It's Rockwell Automation. It comes back with a serial number. It'll also have a firmware revision. We're making some UI changes to make this a little bit better, but if I come down, I can see more information about that thing. I can see firmware revisions, so I get a real-time asset inventory. If I walk over and plug something new in, it shows up, right? And I'll have log entries that say this device showed up on this port of this switch. It's attempting to talk to this device, that device with these protocols. So I will have a nearly real-time asset inventory. It's very, very accurate, right? And one of the features that we're building in more and more of is, so you see deep packet inspection on the ICS Defender. Well, we know a little bit about deep packet inspection and asset identification. So we're building more and more of that functionality in. So if you want to know what's on your network today, you'll know in nearly real time. And it'll be up to date. And you'll know what's cabled to what. How many times, Ken, did we try to troubleshoot a piece of equipment at GGA where they swore it was cabled according to the print? Many, many, many times. We finally sent a guy down to Mexico because Sergio was on vacation that week, so he was would have been our man on the floor at the time. Guess what? Dave Smith. I remember the phone call from Dave. Yeah, this ain't cabled like that at all. I'm like, well, maybe that's why it ain't working like we expect at all. I could be sitting in my desk, bring up this topology display, and I will know exactly how that network is cabled. It's not maybe it's cabled that way, it's cabled that way, okay? All right, any more questions before we move on? Just so we don't run out of time. Of course there is.
Couple of quick questions just about security. How does does it use a different technique for identifying the individual nodes, the clients and the host machines, other than just the MAC addresses? And secondly, if you had a very wide area network like across continents, would your best bet still be using VPN tunnels across those? Or is there something even better, new, improved that SDN can do to convey across, internet backbone?
Okay. Two questions. First question is, what do we know about devices? And this is an area we're building out. I'm going to pick on Rockwell because that part's already in place, right? The large majority of the customers in the US use Rockwell, so that's where we started. When I said a minute ago, some Yahoo, let me get to the right page. Let me open this up so that you can actually see where you're going. When I say some Yahoo typed HMI in here, we know that's a PLC because we pull back the product code. We do what's called a get attributes on the device because we know that it's a SIP device because we see the traffic. We pull back the product code, firmware revisions, a half a dozen pieces of information on that. We fingerprint with that device. So it starts with the MAC address. Then as soon as we see any traffic from it and we know what it is we're talking to, we go out and ask it the explicit question, who are you? And then we fingerprint that. And if I move this around, it better match the fingerprint when it plugs back in. If I see that MAC address and I see that serial number plugged back in, but guess what? The product code is now 7 instead of 13. It will be quarantined automatically if you choose to do that. It can move the device to quarantine and pull it off the network automatically. Magic-like, right? That's that control piece. Because it should never change product code. Ever. Never. Right? Same thing's true with other types of devices, right? So as we move into other areas, we're going to do some of the more other common protocols the exact same way. We're going to fingerprint those devices. The other question was, how would you use SDN across the world? Well, in the case of Genesee County, all their SDN connectivity is over 900 megahertz Wi-Fi between 2 ICS defenders, right? All that remote connectivity. Other customers, who's heard the word SD-WAN? Hasm, once again, you can't answer. Hasm is a very, very experienced IT guy. He has the answers to these questions I'm asking, which is why he is off the table. Okay? SD-WAN, it's SDN for the WAN. It's the same technology that I said was rolling through the enterprise space, SD-WAN, right? Now, are there some caveats to it being like SDN like we're doing? Yeah, a little bit. But by and large, the technology, the idea is the same. So in those cases, Jim, if you're going straight across out over the internet, then absolutely something like ICS Defenders, right? If you have a large corporate WAN and you want the control that SDN offers in the full enterprise space of a large WAN, absolutely SD-WAN, right? Would I take our controller and put it on 10,000 switches across 14 sites, all with a single controller? Yeah, no. Not built for that. This is an OT. This is meant for the plant floor. Can we handle a lot of stuff? Yeah. Do I want 10,000 switches on a single controller with a bajillion devices below them? No. Okay. The controller can run on pre-built hardware we have for it. We have a DIN-mounted controller over on the other side of Ethan there. That's running that whole SDN network over there. We have a rack-mounted version. Or we have customers that have virtual machines. And much like the ICS Defender, who has you can load it virtually on something, the SDN controller can also be loaded in a VM. Right? Great questions. Any others? All right, let's move on.